Hi everyone, welcome to the Art of the Possible series. I'm Nihalini Yogi and I'm a principal cloud solution architect at Microsoft focused on advanced networking and security. Today's topic is connect to MCP Model Context Protocol servers in Azure AI Foundry service. Remind you, as you could see, this is a preview service. With me, I have two of my amazing colleagues today, Jacob and Gabe, and both of you, I've really enjoyed working with you and the journey throughout and your collaboration, bringing developer insights and being available to help me see things with developer eyes. So in this video, it is a part of a broader series on AI Foundry, and we will be envisioning in the specific video, we'll be running the envisioning session, the big picture, focus on tooling, and followed by a fantastic demo that Jacob has planned out, and I want to share his repo over here. We will also put it in the description below. With that, I will turn it over to you, Jacob and Gabe, to introduce yourself. You go first, Gabe, and then Jacob.
Sounds good. Thank you, Nahali. Thank you for the opportunity to give us a platform to present here as well. So I'm Gabriel. I'm an escalation engineer for the Azure AI Foundry machine learning support team. Jake.
And I am Jacob Sender. I'm a senior tech support engineer for the Azure AI team.
Awesome. Really great to have you both on the session. And with that, I will turn it over to you, Gabe, right? You go first.
Absolutely. All right. Let's go. Let's get this started. Thank you. So today we're going to be going over AI Foundry agents. So I wanted to give a quick overview of what these are, right? AI Foundry agents are intelligent, task-oriented entities designed to perform complex operations by combining reasoning, customization, and action. Think of them as modular AI workers that can be assembled, equipped, and orchestrated to solve enterprise-grade problems securely and at scale. At the core of every AI Foundry agent are three core components. That would be your LLM, your instructions, and the tools, right? So what is LLM? LLM is a large language model, and this is the agent's brain. These models, right, provide the agent with its reasoning capabilities, enabling it to understand context, interpret instructions, and make decisions. You can choose the model that best fits your use case here, balancing performance, latency, and cost. Instructions define the agent's personality and behavior. They act as the blueprint for how the agent should respond, what tone it should use, and what task it should prioritize. These can be simple prompts like your helpful assistant, or more complex domain-specific directives that guide the agent's interactions and decision-making. Last but not least, we have tools. They extend the agent's capabilities beyond just language understanding. They allow the agents to interact with external systems, retrieve enterprise data, and perform real-world actions. Some examples would include Azure AI Search for grounding responses, Azure Functions for event-driven logic, and OpenAPI integrations for calling external APIs. Tools really transform agents from passive responders into active problem solvers. Now, together, these components form a flexible and powerful framework for building agents that are not only intelligent, but also actionable and context-aware. Today, we're going to be going over a little bit more about a specific tool. So let's talk a little bit more about what are tools, right? In Azure AI Foundry, tools are functional extensions that allow agents to interact with external systems, retrieve data, and perform real-world actions. They are what transform an agent from a passive responder into an active participant in workflows capable of executing tasks, automating processes, and grounding responses in enterprise data. Tools tend to fall into two major categories. These would be knowledge tools and action tools. For knowledge tools, they enrich the agent's understanding by providing access to structured and unstructured data sources. They help agents retrieve relevant information, ground their responses, and maintain context. Some examples of these would be some private data sources, for example, Azure AI Search, Microsoft Fabric. You could also have public web data, right, connecting to Bing, and things like that. The other main tool would be action tools. These tools are what enable the agents to take action. So they can trigger workflows, call APIs, execute functions, etc. Some examples that we have would be Azure Logic Apps, right? Low code, no code workflows for automation, the Open API spec tool where you can configure it to call specific APIs. You have function calling where you can define your own functions, and the agent can make stateless custom functions for lightweight logic. And each tool is configured with metadata, authentication, and invocation logic. Once attached to the agent, the tool becomes callable during runtime, either automatically based on the agent's reasoning or explicitly via prompt instructions. Today, we're going to be going over the MCP tool, which allows agents to use a MCP server, right, or MCP endpoints for advanced context handling. With that, I'll pass it up to Jacob to go over a little bit more about the MCP tool.
Great. Thank you, Gabe. I am going to take over control of the screen real quick and share us over here. So what is the MCP or Model Context Protocol? MCP is an open source standard for connecting AI applications to external systems. It allows things like Claude or ChatGPT or other AI applications to connect to local files, databases, and other programs. To the AI, MCP connections look like a list of tools, prompts, or resources that it can use to gather knowledge to answer a query or to take action to fulfill a user request. The AI can call these by simply writing JSON. All the rest can be abstracted away from the agent itself, which improves accuracy and reduces unnecessary context. We've got a little diagram here just of how it looks. The MCP protocol itself is created by Anthropic, and they themselves describe it as like a USB-C port for AI applications, a standardized way to connect just about anything to your agent. For some examples of those possibilities, we'll take a quick look at the MCP registry on GitHub, which are some of the most popular MCP servers that are available to connect to your AI applications. Since MCP opens the door to so many possibilities for your AI applications and agents, we'd like to explore how to use it with Azure AI Foundry today in particular. For instance, we could take a look at some of the more popular ones like the Playwright for adding browsing capability to your agent, or you could add Stripe for billing APIs, invoicing, and so on and so forth. We won't go into a deep dive on the protocol itself today. We're going to focus specifically on the agent integration with MCP servers and giving you enough background to understand what's really going on. But before we get into the demos, I'm going to pass it over to Nahali again to do a quick envisioning session, and so we can better understand how it works behind the scenes.
Thank you, Jacob and Gabe. Great presentation. So let me share my screen. You guys can already see my screen. I'm going to show the big picture. I'll bring a little bit more of the network eyes and focus on tooling, concepts, and some of the considerations for troubleshooting network components from the end-to-end flow perspective. Okay, so what you see on my screen is a weather API. They are public-facing external APIs that pretty much do the same thing. I have listed the URLs over here that do the same thing. They return weather data in JSON format. Okay, but the JSON format could be different across different APIs. So with that, let's look at what a client would look like and how things worked before MCP, right? So we start with the API, and I'm using the REST client, which is baked into VS Code, but you could do this calls programmatically as well. So the way it would work is this client will directly talk to these APIs, and let me show you a quick demo of that. So here I am in my VS Code, and for those of you who are more on the network side and curious, the REST client that I'm using is this one. Okay, so it's a great client, great tool to have in your tool belt. And with that, let me show you what it will do. So we can just create a .rest file and put these kind of API calls, and then there is a little send request button over here. So let's click that. And here you can see I got a 200 OK and the response in a JSON format. Likewise, this is a different API. As you can see, I'm making a call to a different HTTPS URL, and there I got a 200 OK on that one as well. It's a much abbreviated JSON response, but as you can see, they're both different. Okay, so that was the first demo directly calling the external APIs. Now, let's bring MCP server to the mix. So MCP is a client server architecture. Here you could see that you have an MCP server. There are different type of MCP servers. Jacob showed before. I will be showing the demo with the GitHub MCP server, and later in the video, Jacob has done it programmatically using Python. Okay, and from a client perspective, so the role of before we go to the client, the role of this MCP server is to expose the tools. And I have listed the roles in this diagram as well. So the role is to expose the tools. And what do we mean by that? And we'll look at that in the demo. Now, let's look at this client here. And there are different type of clients. In my case, I will be using VS Code with GitHub Copilot as a client. Jacob's going to do a deep dive on the NPX inspector as well. It is a great tool to have in the tool belt. So in this case, these are the MCP client. This is the MCP server, and then there is a layer of transport. This transport layer is nothing but a communication channel for all of the JSON RPC messages that happen between the client and the server. And then there is the layer of the host. So host is where the LLM agents are. So here in this LLM layer, or the thinking layer, I call it, there are different, in my case, I would be using GitHub Copilot agent, which would be running the LLM. So it would be running, let's say, GPT-4o. And later in the video, we will be showing you the AI Foundry agent which will be acting as the LLM. Anything I missed or you would like to add, Jacob, Gabe, on any of these different boxes or layers, if you will?
I'll add just one thing. I want to call out the normalizes access role for the MCP server and emphasize that it's allowing the agent to not know everything about each of the REST APIs. It can just write some JSON and call them. The names of the tools are in natural language. The errors that it get back will be in natural language and explanatory. So it's a really valuable improvement over just calling REST APIs or functions with your agent for those reasons. It is meeting the agent where it's really good, which is writing JSON and dealing with natural language.
Thanks, Jacob. Great insights. Yeah, and it sets it up perfectly for my next layer, Jacob, which is where we show the end-to-end flow. So I'll kind of put put it in the center so you can see. So let's look at the flow end to end, and then I'll do a demo. So here you could see the green path is where the user will start the query in a text or a natural language. It will then go to the LLM layer here, as you can see, and then from LLM to MCP, it will pick the right tools. So the tools get exposed on the MCP server side, and I'll show you that in the demo. And from the MCP server to the API, this is the green line over here, where it will talk to the APIs. So essentially, this MCP server is acting as a middle layer or a bridge. Okay, and then as part of the flow, the pink flow that you see, um, the data flows back, like Jacob mentioned. It will also get normalized and sent back over here to the MCP host, and then the fully summarized data is then returned to the MCP client. Anything you want to add to the overall flow?
I think you covered it pretty well, Nahali.
Same here.
Thank you. Yeah, and so I do have one layer before I go to the demo, which we will see in the demo as well. But this client could ask something like, "What is the weather in Boston?" And then the tools that I have exposed are these two tools, and then this is what the MCP host, or which runs the LLM, would show you which tool it is using. Okay, so let's real quick jump on the demo. Again, this is designed to be just get you guys familiar with the tools. And so here I have, let me jump back over here. Here I have an MCP server, very simple MCP server running. And again, this was built using Copilot and my human Copilot, Jacob. And so it is a very simple server that I'm running. And the big thing that I want to focus on here is the tooling. And so when you have the MCP server running, you could use a tool called the inspector over here, which takes you to this kind of user interface, poses this UI, and you can connect to it. And I just want to stitch together the other transport modes that I mentioned, and then you can connect to it using this URL. And when you connect to it, you can list the tools. In this case, we have this tool that is fetch using that particular website API. And then if I run the tool, it will give me the weather in Boston. Okay, so there we can get the weather in Boston. Now, the reason this layer is important is if you strictly come from networking, look at it from networking eyes, it breaks down your troubleshooting into communication between first the MCP server and the external API. That's all that tool is doing. So it's important to kind of have that in your tool belt. And then lastly, I will show you the demo from the actual MCP client. So and the MCP host. So in my case, it's a combination of VS Code and GitHub Copilot agent. So here I am. Let me open the GitHub Copilot. So this is that little toggle. Be sure that you are in the agent mode. Notice that my LLM here is selected. And if I click on this little tools icon, you can see that I have a tool called, let me find my tool here. Local weather is, and you can see that these are the two tools exposed, and kind of coming back to how I am exposing it. it is all done in this MCP.json. So this is how, and notice this little icon over here, it's not started. So we will be using the client here, and I'll say, what is the weather in Boston? And notice that the MCP server is in the file setup configured in a file called mcp.json in that local directory. And notice this little icon, it will automatically call the right tool and it will start the server. So you could see that it has already figured out which tool to use, but I do have to allow it. And there the MCP server is now turned into the running state, and it's running, and it should give us the weather in Boston. Okay, so this is where we are showing this end-to-end flow from all the way from client. That other inspector tool that I showed you helps you break it down, your troubleshooting right between the transport and the MCP server. Anything else you would like to show here in the screen? Anything I missed? Okay.
Looks good.
Okay, awesome. So there's one more short demo that I want to show you, like just to bring down, this was a little bit difficult for me when I was learning about this in the beginning, because there's so many combinations of clients, of different hosts, different servers. So just like how we did this on a locally running a Python-based MCP server, Jacob showed you that URL with lots of publicly available MCP servers. I'm going to use one of them to show you a quick demo, the one with the GitHub MCP server. Okay, so if you go to that one, there is this registry, and if you go there, you can literally just grab these kind of VS Code snippets and put it in your this mcp.json file. So there I have my GitHub snippet over here. And if I say, and notice that the server is not started. If I say list all my GitHub repositories, let's see what it does. It's demo time. And there it is showing me all of the repos and the status of the server turned to running. And now we are coming to the part where we are going, this is the meat of the discussion today, where we are going to show, Jacob's going to show this end-to-end demo. But now you can see that this layer, the MCP host layer, is the Azure AI Foundry agent. So the flow would look something like this. We're going to have the Python-based client talk to the MCP server with this layer of LLM in between. Jacob, feel free to add any more details. I know you have prepared a great demo, so may hide the layer of API as it's no longer relevant, but you are programmatically exposing the tools, right?
Yes, I am. And I think having the two MCP hosts here side by side really illustrates what we're trying to do here, which is to demonstrate how you would build something like the GitHub Copilot agent yourself, or how you could connect that to your local data with an MCP server, right? So the demo that I'm going to give is going to come in two parts. The first, we'll just work with a very simple example using the Azure AI Foundry SDK, and we'll connect that to an MCP tool that is pointing at the Microsoft Learn MCP server. So we won't do anything with the server except point to the URL. There's no authentication. It's very simple, but we'll just demonstrate the SDK functionality and where we're currently at with Azure AI agents and the Foundry with using MCP tools. Then we'll jump into a little bit more sophisticated demo where we'll run our own local MCP server, just like Nahali was just doing. That's going to have tools exposed to the agent that allow it to manipulate a database that's running on my local system, just a simple SQLite database. So we can kind of see the whole end-to-end process, how you would spin this up from a developer's perspective, and cover a lot of the concepts you need to know along the way.
Awesome.
So
Thanks.
yeah, I will take over the screen share again. And we are looking at the Azure AI Agent Demos repo that Nahali had shown us earlier. I am going to start us here with using the SDK to build these agents and connect to MCP tools, because in the Foundry at the moment, if we take a look at a new agent, under the actions where you'd normally add a tool, we don't currently support the MCP tool in the Foundry UI. So we'll come back to the Foundry to look at some things later once we have got an agent created with the SDK, but the support for MCP in the Foundry is limited at the moment in the UI. So jumping back, let's get into the Microsoft Learn agent without any further ado. So first of all, we've got a quick file overview. Create agent here is, we've got two Python scripts. The first is create agent, and it's going to create us a new agent using the Foundry Agent SDK. Ask agent is a simple chat loop that we can use to interact with that agent and see the results. We've also got some bare bones documentation on MCP. We've got the step-by-step README and a sample environment file that we'll copy over. So we are going to walk through the quick start and README essentially to get going. And let's see, I've got a terminal over here. We are in the a freshly cloned copy of the repo, so I'll be doing all this right in front of you as well. Okay, so we will be following the README step by step, and I've pulled up a terminal in the repo here, and I'm working from a fresh clone, so it'll be just the same as it is for you. We will start, of course, with Python virtual environment. Cool. Python free virtual environment. And source that as well. And now that that is done, we'll install our requirements. The main two being the Azure AI Agents SDK itself, and also the Azure AI projects package as well. Those are the two that we'll be working with to work with the Foundry SDK. And then we'll copy over our sample environment to its own .env. I'm going to pull that up real quick just to show what it looks like. We've got just a project endpoint for our Azure AI Foundry project. We have a model deployment name that we'll use, the name of the agent that we're creating, and finally an optional agent ID we can set. So the create agent, which we will take a quick look at now before we run it, is quite simple, right? We've only got about 50 lines of code here. And what it's going to do is create an agent using the SDK. First, we'll get our project using our project endpoint. And then we will create an MCP tool object, which points at the Microsoft Learn server URL, MCP server URL up here. Oh, go ahead.
And Jacob, where would I get the project endpoint and model deployment name? Where would these
Oh, absolutely. We will need to set that in our environment as well. So I am, this is, like I said, just like you were going to see it, there's nothing populated in here. So we'll start by getting that project endpoint. I'm going to pull up the Foundry and go to the overview. I'm assuming that you've got a project created. If you create an Azure AI Foundry resource, there will be a default project created as well. So I'm going to copy the project endpoint from the overview and paste that into our project endpoint here. I've also, we're going to need a model. So I'll jump over here and I'm going to use GPT-4o. There are quite a few models supported. All the 4.0 series, 4.1 series, and 5 series are currently supported. well, the 5 series is limited what tools it can use at the moment. I'm just going to use 4.0 as the good old standby. And we will save that, and our environment's ready to go. So jumping back over to create agent, we've got our endpoint, we've got our model, we've got our agent name. And once we create that MCP tool, we're going to define some instructions for the agent as well. We're going to tell it about what tools it has and tell it to use those tools when appropriate, right? These natural language instructions are, it's quite important how you prompt your agent, how you instruct your agent to use these tools. If you're too ambiguous in your question or too ambiguous in your instructions, you might find that the agent doesn't use the tools when you would like it to. So we're just going to very cleanly tell it that it's got an MCP Learn or a Microsoft Learn MCP tool, and to use it when we ask about documentation. After that, we're going to take our project. We're going to create a new agent and assign it the model, the agent name, the instructions, and finally this learn MCP.definitions. We're going to define the tool at the level of the agent, but we're not going to pass anything like authentication or approval for MCP. We'll talk about approval later, but we're just going to give it the shape of the tool so that the agent is assigned with that. As a quick note, you can give tools, you can assign tools at the agent level or at the thread or run level, so that an agent, for example, maybe doesn't persist a tool. You just tell it to run it with a tool once. This is all a choice you have. Authentication is always handled at runtime, but maybe I'm getting a little ahead of myself. We'll go back to just the simple demo for now. We'll create this agent. So with all that set up, we'll run create agent. Give it just a second to go through, and we've created an agent. So we've got confirmation we've created an agent with this name, and we've written an agent ID, which we'll use to reference the agent when we run our chat loop. So if I go back to the Foundry here and refresh, you can see that we have indeed created a new agent. And if I scroll over, it has an MCP tool attached. So that is showing here in the Foundry, even if we do not yet, let me drag this over real quick. There we go. Do not yet allow you to add one here. I want to demonstrate real quick that we can try to open this up in the playground and try to ask a question like, show me some documentation about, let's do Azure function apps. And we'll run into a problem really quickly where the agent can't actually complete this. And we'll talk about why a little bit further. But again, we're not supporting MCP tools in the Foundry UI. So hence why we're using the SDK. But this is all coming. So now we want to use our agent, right? We've got our agent created. I'm going to jump back to our README and look at the next steps. This is what we ran. We ran Python create agent. Now we're going to chat with the agent and run ask agent.py. And we've got some sample questions here that we can pull up. And chat is ready. So we're just going to copy one of these and see how it works. The chat loop that I've created gives some status updates as we go. So you can see that we've created a new run. It's queued. We can see the tool call that was made. And in fact, I should ask this agent what tools it can see as well. We'll do that next. You can see that the agent's creating a message, and here's the output from that. Here we go. Here we've got the tool call ID and type of the tool that was run. And you can see it came back with a bunch of documentation about Azure functions. So that's great. We'll also ask what tools can you see? The agent's going to run and come back. And these are all three of the tools that are that come with the Microsoft Learn MCP server. So we've got a doc search, code snippet search, and a docs fetch. So that is all working as expected. That's excellent. If we pop back over to the Foundry, we can take a look at the agent playground. Go back. Here we go, agent playground. And look at our threads. And in our threads, we will be able to see logs for the thread we just ran. So we've got, show me some documentation about Azure Function Apps. And we've got the response. Sorry, this was the one we tried to run in the UI. This is the one we ran with Ask Agent, where we've got find docs on Azure Functions, triggers, and bindings. We've got the response. We can pop this open in the playground as well. I'm gonna recommend it. Okay, not the time for a survey. We can see, even if we can't use the agent yet in the UI, we can see the output of a thread that we tried, right? So we've got the docs here that's all formatted nicely. The results from all the tools are passed to the agent to answer the question, right? So if we pop open the run info as well, we can see this at a more granular level, where we can see the thread that we created when we started chatting with this agent. We've got the first run where I asked it to find some documentation. And then in that run, the agent decided it needed to call a tool. And so it called an MCP tool. We can see in here the arguments that it passed to that MCP tool, just in JSON, and the output of that tool, which is going to be quite long, right? All the documentation for the tool call. And then the agent created a message back to us with those documentation, with that documentation. And the next,
real quick, I think it's important to see here as well is that if there are any problems with tool calls, let's say your prompt was not well formatted enough, you would be able to look at the thread and see if with the prompt given or instructions provided, if the tool call is being made to begin with, or if there were any issues with calling the tool, you would be able to see errors here, right? So looking at the threads and looking at the steps the agent has taken to execute your specific prompt is very important for any debugging and perfecting your prompts and instructions.
Yes, exactly. So I think for Azure AI agents in the Foundry, this is a screen you will see often for debugging, working through all the inputs and outputs and prompting and any errors that are in here to debug your agents. So I can also demonstrate that really quickly if we pop back to the agent playground and create a new thread with this guy and try to run it in here. We know this isn't going to work, but we can also explain why. So let me give me some docs about Azure AI quota. We know this isn't going to work, but we're going to look at the thread logs and actually see what Gabe's talking about. We've got the error here, requires action. You can see that the agent tried to run the MCP tool. We got to in progress, and then the call failed on requires action. What this is telling us is that the agent requires approval. And this is a concept I want to introduce for MCP tools. It's another valuable part of the protocol, which is that you can specify whether or not you want the agent to ask the user for approval to use a tool. For looking up documentation, that's not really something you would care about probably, but for pushing code changes, maybe you absolutely want to review what it's going to push before you allow it to do the push. So in this case, the Foundry UI, right? This is a preview. We don't have a way in the UI yet to give approval for the agent to use the tool, or for the agent to ask for approval, that so on and so forth. So we run into this error requires action. When we are using this in our Ask Agent loop, this is a good segue back into our code, and we'll take a look at how the Ask Agent works. We've got the Microsoft Learn MCP server again. We've got an event handler, and we've got the code where we've again got our endpoint. We've got our agent ID that we're pulling from our local file that we saved, setting up our project. And here, with our MCP tool, we're redefining it, rebuilding it. And at runtime, we set this approval mode. This can only be set at runtime. And we're telling the agent that this MCP tool never needs approval in this case. And you can do this per tool. You can do this per server. You can do this, with different circumstances, maybe based on user permissions, that sort of thing. The point here is that we don't have a way to set this in the Foundry UI, but we are setting it for our Ask agent, so we don't run into that error here. So that's really the meat of what's going on in here, right? Is that we're redefining this MCP tool, setting that approval mode to never, and then down when we're actually creating a run to ask the agent something, we are giving the resources for the MCP object before we had set the shape of the MCP tool, right? The definitions. Now we're giving the resources from the MCP object to the call, and that's all our runtime parameters. So this is where authentication would also go in, and we'll see that in our later demo. But this we want to pass that at runtime. We don't want to persist that on the agent itself. So I think that is everything that I wanted to cover for this first demo. Oh, yeah, go ahead.
Would you like to show how in the Azure portal, just the networking bit right now, Foundry is deployed with public networking, correct?
Oh, yes,
so if
absolutely.
You go to, so if we
this
go
is
to just,
a stock standard Foundry project. So at the moment, like I said, we're in preview. When you are using a network secured Azure AI Foundry, right, private MCP servers deployed in the same virtual network can't be reached. You can reach publicly accessible MCP servers. But for the sake of this demo, I am using a completely public, and we can pop this open and look at it if you'd like.
On the top right, I believe right next to JC, at the drop-down arrow.
Oh, yes.
Yes.
Oh, no, not that one. Is it this one?
Yeah, it should be. And then you see, go to the resource group.
Yeah, I just wanted to call out and record the the network settings for this deployment.
Yeah, absolutely. Like I said, we're on stock standard. Everything's allowed. No private endpoints, no network injection, just all networks access is allowed at the moment for this guy.
Basic agents as well. So if you look at the network injection tab, we should see an empty agent. Yeah. If this was standard, we would see a delegated subnet for the agent service here. We covered this on our previous videos as well, if you're interested in that. Nahali, you were saying something, sorry.
Yeah, no, that's great. Yeah, so good call out, Gabe. And so it is not supported currently with standard agent. Is that right?
It is. You are able to use standard agents with MCP servers. The constraint we have is accessing private MCP servers. So if you deploy a secure AI Foundry, you would be able to reach a public MCP server. But if your MCP is hosted privately, we wouldn't be able to access it. So Foundry can still be network secured, but the MCP server itself would still have to be public, right?
And that's obviously a use case that's top of mind, right? Is you have data on a database or on a container or something like that that you are looking to access that is private, that you don't want, flowing over public networks, public internet. So that is something that is certainly, top of the list to come down as well. So I am, that is just about everything I wanted to cover with this very basic first demo. So I'll go ahead and close out of that. Do we have any other questions? I do want to pass it over to Nahali real quick before we move on to the local server demo, to sort of give the high-level overview of that again and explain what else we're going to be doing with that, especially from the networking flow side of things. These agents live in containers in Azure AI, right? So they can't access a local MCP server that's running on my laptop unless we expose that local server over the internet. We're going to use ngrok for that, and I think Nahali has a great little explainer on how to do that. So I'll pass it over to you, Nahali, before we move on to the next demo.
Awesome demo. Thanks, Jacob. Let me share my screen. So I'm going to demo and show the visual for the ngrok tool, which is a developer tool. And typically the way it's used is that you would run the server locally on the developer machine. And if it needs to be exposed to the public, the tool is used, ngrok is used. And the way you would expose it is using this command. And we'll put a detailed link below. And so what it does is it exposes this public facing URL, and essentially behind the scene, it forwards it to localhost 8080. And then the way the flows would work is now the user can hit the public facing URL and reach the behind the scene, the local server. So essentially, ngrok works by creating a tunnel, a secure tunnel between your local machine and the ngrok service. So next, I'll show you a quick demo locally on my laptop. So I'm going to just trigger a very simple Python server over here. Clear my screen here. So let's say I'm running a very simple Python server over here on my laptop. And if I call this locally, localhost port 8080, it says this is running on Nihali's laptop. But what if you want to expose this publicly? Developers develop on their laptop all the time, but if they need to test this securely, there is a tool called ngrok, which first time I heard about it, I didn't realize that it was a very popular tool amongst developers. So I want to share this insight that it's very easy tool. So let me show you how to expose this publicly, and there is a setup doc that we will include in the link below, but essentially you just run ngrok like this. So now it exposes your local server using this ngrok URL. So we'll just grab this and now you can be anywhere and access this. So what we'll do is we'll grab this URL, we'll quickly jump on a VM in Azure. Here I am on a VM in Azure, completely outside of my local network. And if we curl this, it will say this is running on Nihali's laptop. Okay, so basically it just, so from a visual perspective, it just exposes a locally running app via HTTPS. So you get a valid certificate and then an outside user can hit it. Anything you guys want to add? I thought it was a very useful tool and pretty common in developers, right, Jacob?
It is, and nothing I want to add. This is a great way to test over the internet.
Awesome. So
I
over
think
to you.
it's important to emphasize that without this, you will not be able to access your servers using the AI Foundry agents. Given that these agents are running on containers in Azure, it would have no way of accessing your local host. So it is imperative that you expose any local server remotely so that you can actually access the MCP servers. In real world, we will likely already have a publicly exposed server, but in case of when you're doing demos or POCs, right, and you just have a local server running, it's important to remember that we need a way for the agent in Foundry to access the server.
Right. So we do have a little bit of documentation on self-hosting an MCP server like this on Azure Container Apps or Azure Functions to get a remote MCP server endpoint that you can connect to from your Azure AI agent.
Awesome. Yeah, we'll put the link in the description below then.
Absolutely. So shall we proceed with the next demo?
Sure. All yours.
Okay. I will share my screen and we will come back to exactly where we were before. I'm going to go back to the top level of the repo and move over to our local server agent. And we'll just do that as well over here. And we will get started. So with our second demo, we're going to build our own MCP server to run locally. And it's going to expose tools for the agent to connect to a database on my computer. In here, we've got the custom local server, which exposes tools to access a SQLite database containing some sample information about music artists and albums and sales and so on. We've also got the agent, which is very, very similar to what we just demoed. We will add authentication since we're exposing this server over the internet. And also, we've got an optional verbose mode in there if you're interested in seeing more about the ins and outs of what the agent is doing. And finally, we have a few instructions on how to set up the MCP inspector client that Nahali demoed earlier. That's an interactive developer tool that's often used to test and debug MCP servers. We'll take this in steps. We'll walk through the repo just a little bit. We'll run the local server and inspect it with the MCP tool. And then lastly, we'll publish that local server with ngrok, like Nahali demonstrated, and create an agent that points at it using the Foundry. So starting with the server directory in here, I just want to quickly run through the repo so we understand what's going on. The server, we have some docs on it. It's the server itself. We've got a little schema diagram, and we have, most importantly, the database itself, right, which is called Chinook. It's a popular database for testing with SQLite, and a little client that connects to it from Python. We have the surface, which is all of the tools, prompts, and resources that it exposes to the agent. So in the README here, I've got a little bit about what the server exposes. We have a variety of tools that are available to play with. We've got both tools that are very specific in their scope and then some more general tools allowing the agent to actually write and read SQL as well, but we'll cover those in a minute. MCP also talks about resources and prompts. We won't go into those too much here. You can read more about those, but we do have examples of those in case it's interesting. If we pop into the surface here and we actually look at what one of these tools look like, we will start with, let's see here. In the register function, this is all built with fast MCP, I should say as well, which is kind of like fast API, but for MCP servers, it's just an API that has one endpoint, and that MCP endpoint has all these paths for different tools. So we'll look at just this list tables to start with, right? We've got no arguments. We define it as an MCP tool. And each of these tools we're mapping an operation the agent can take to the actual query. So the agent doesn't need to know the query. It doesn't need to know the schema. It doesn't need to know anything. It can just run the tool to answer questions that apply. If we look at another one of these down here, like maybe the insert customer, we can see the parameters that we've got for inserting a customer into the database. Again, we're abstracting away the schema and just giving the agent exactly what it needs. We also, as you can see here, have very nice natural language errors so that if the agent fails to call the tool for whatever reason, it can recover and figure out what it did wrong. This is great for reliability in the scenarios that we expect people to use these kinds of tools for. Let's see here. So we will also give the agent, I think, it's important to have these tools, right? We're mapping that operation to a query. We don't need the agent to know about the query. It can be difficult to figure out from just a schema how a database is supposed to work, what data is supposed to be in there, so you can abstract that away from the agent. But we do have some of these in here as well, just to demonstrate how they would work. I've split out read operations from write operations. That's, for example, you could require approval for write operations, but not for read operations. That might be something you could play with on your own. So those are some of the tools. Really quickly, any questions, comments before we move on?
Oh, looks good so far, Jacob.
Okay.
Looks good.
So I will go back to the server itself here, and we will continue. The other main piece of what's going on here, we've got a little bit for authentication and configuration and so on and so forth, but the other primary piece of what's going on here is the server itself, which lives in app.py here. Again, we're using fast MCP. We're instantiating that here with the server itself as the name. We register all our tools and prompts and so on and so forth. And that all is going to happen right here. The only other piece of this that I want to cover, just so we don't get into how to develop a Python tutorial, is that we are adding a little middleware here for authentication. And that we're adding to this path. We're going to set a local token just for demo purposes in our environment, which the server will pick up and which the agent will pick up. And we'll cover that more in just a moment when we run this and look through the MCP inspector. I think the point of me showing all this is that if you're at all familiar with web development, it's not complicated, right? This is a 69-line Python file to run the server, and we've got our own connection to our local database set up through MCP. So again, want to stop, pause, any last questions, comments before we work through the setup? Should only take a couple minutes, and then we can be looking at this through the MCP inspector.
Looks good,
Okay.
Jacob.
Okay, then we will continue. So each of these, let's go back to the top level here. Each of these, the server, inspector, and agent, they have readmes of their own for more detailed setup, troubleshooting, configuration, whatever. But at the top level here in our README, we have two flows, the local learning loop, which we'll start with, where we're just working with the local server and inspector. And then the second flow where we are using ngrok to expose that server and connecting to it with the Azure AI Foundry agent. I'm going to start with just the quick start for A, and we'll just walk through this one step at a time. I'm going to deactivate my old environment and create a new one here. They're mostly the same, but oops, I did that again. On 3. They're mostly the same, but we'll just do this anyway for purposes of demo. Install our requirements. I'm going to copy over our sample environment, which is a little bit more, we've got a little bit more going on there. So we will pop into that and take a look at it now. The, let's see here, vim.env. So in here, we've got our project endpoint and model deployment name as before. So we'll just fill those in real quick. This is how our agent is going to connect to, this is for when we create our agent, right? How we connect to the Foundry with our agent. But let's see, project endpoint, there we go. Copy, paste. But we've also got some more in here. We've got a local port and path for the MCP server itself. We have server database, the database paths for the server, right? So we've got where the server is located. I've set this up to use a working directory that is overwritten every time you restart the server. So we can also enable persistence for that. This is just to make repeated demos a little bit easier. You can play with it without worrying about getting your repo into a bad state. We've also got a local token that we can set in this environment, which we will come back to later, and the public server URL, which we'll need to stick in here so that the agent can pick that up and know where to connect to. So that's our environment for now. We should be all set up to run the server. So I'll do that now as well. F3 module server.app. We should see that we're starting a server and we're starting the server. So we've got that running now. The next step is I'm going to pop open a new window here and bring that up. And it's actually that up here and put this guy down here. We'll back. There we go. Bear with me while I back this around. We're going to go back to our demos. We're going to go back to local, and we're going to now run our model context protocol inspector, the same thing that Nahali had run earlier. We've got 2 NPXs in there. If you need help with setting up Node or anything like that for this version, I've got some step-by-step for every platform in there. This is going to run. This is going to start. This is going to pop open in our browser. And from here, we can connect to our server. So we've got it already. Just because I was playing with this earlier, we've got the right URL punched in. Make sure that you've got the MCP path on the end there. We are going to be using streamable HTTP for our transport. I think Nahali briefly mentioned there are a variety of different transports available for MCP, different ways to connect between your client, host, and server. In this case, we're using streamable HTTP, which is the recommended for anything over the internet, of course. SSE is still supported, but deprecated. And then STDIO is exactly as it sounds. It's great for testing locally, but we'll just use streamable HTTP as that's how we've set it up. We've got an authentication panel here as well, which we didn't set yet, so we'll just connect without authentication and hit connect. Our server accepted it. We've got a few things going on here too. I want to call out the history especially because it's going to be valuable. We can list our resources. We've got a schema snapshot, which we can run, and we get a little bit of a snapshot of what the schema is. There we go. We can see it a little better. But the most interesting thing here, right, is the tools, right? This is what the agent's going to be using. And we can see we've got all our tools from our server that we exposed. If we pull up the insert customer again, we've got all the options that are populated in the MCP inspector. Again, very, very handy for testing, debugging. Let's go ahead and just run the top N customers to test it out. You can see we've got the logs here for our MCP server, and we've got our top customers. We can also try, just for fun, we had a limit set of 100 customers. So we can try running this and see the natural language error that we get back, which is going to be really important, again, for reliability, robustness, resiliency for your agent. In the history, we can see all of what's going on here with the request and response. So that is the MCP inspector, and that is our local server running. And just like that, we should be good to go to move on. But I'll stop again for questions, comments, anything like that before we continue.
Jacob, the authentication tab over here, are you going to go over it later, or is it?
I will.
Okay.
I will. We can try. Let's just for fun. Let's punch in. Let's try to connect with authentication. Reconnect. Oh, does it work? Actually, I hadn't tested that. Oh, it still works. You can pass an auth header and it's just ignored. But yes, we'll get back to this because once we expose this server with ngrok, we'll want to, have some authorization. We'll want to have this use authentication for just for basic security.
Got it.
Any other comments? Yeah.
No, I love the details in your GitHub repo. I was just looking at it. It can, it's great for our networking audience as well to follow it step by step. So I appreciate all the details that you have put in.
Thanks. Okay, well, we will close down the inspector and close this as well. Come back to our repo and exit our server. I'm just going to Control-C on that guy. And we're ready to start with our end-to-end. So the first thing we need to do is configure our environment for authentication. We're going to go back to our environment up here. And I'm just going to comment this line and use your demo token as our token and save that. Step 2, we'll run the server again, just like we did before. So we'll run that again. Now the server's picked up that authentication in the startup. and it's going to require that token to work in the future. Step 3, we're going to expose the server with ngrok, just like Nahali covered. Let me just create a new tab here, and oh, that's not going to work. Let me come back to, and we'll just use this guy. And ngrok HTTP 8787. So we've configured that port, right? This is ngrok's just going to expose that port for us and forward traffic from a public URL. I'm going to, we'll run it like this so we can see what we've got going on. From this step, we need to pull out the public URL, right? So ngrok, every time we run this is going to be different, but we will pull up, since I'm using the free version, right? So we will pull up this URL, and then one more terminal. Back to here, and we want to take a look at our environment. And at the end, now we need to add the server URL in here so that the agent picks it up. I'm going to paste that in here, and remember to add /MCP. So we need that path in here. We already have the project endpoint and model deployment configured. So we should be good to go to create the agent now. I will pull that up real quick just to look at any differences from what we had before. Like I said, the main difference is that we are adding authentication. I've added a few little helpers here to make sure that we're actually connecting to an MCP server URL, that we've got that added into the configuration. Let's see here. We changed the name of the agent. We've got the name of the tool here, Chinook. And our instructions are a little bit different. We've told it exactly what tool it has, told it to prefer calling these MCP tools to answer questions. And otherwise, it's about the same as what we had before. Chinook MCP definitions are what we're passing on creation. We're giving it the shape of the tool. At runtime, our askagent.py has, again, a check to make sure that we've actually got a server URL to connect to. We're going to scroll through the agent event handler, which is quite long. Like I said, I added a debug mode so you can see each delta even from the streamed response from the agent to really understand what's going on or to debug with. And let's see, we're setting approval mode to never again. This is where we're setting up our tool. And here we go. So we're getting the local token from our environment. We're going to call this update headers on the MCP object, the MCP tool object here, right? Pass in our authorization token, and then also call out that we are using the local token. We're not going to paste it, but we're going to call out that we're using the token for authorization, just as a little bit of a helper to make sure that this is set up properly. And then we run the same loop as before, where we are creating a run. We are adding the MCP resources, which is going to be all of our runtime settings, our auth, our headers, our approval, and that's as it was before. So we'll go back.
For this server, what is the required approval set to this time? I know we set it to never on the previous one, given that there was no authentication, but how is it configured here?
I did configure it for never here as well. We could certainly change that and play with it. I'll demo it first with never, just for a smoother demo. But yeah, we can absolutely change that to always, for instance, and have the agent ask for approval before it runs tools.
Okay.
Any other questions, comments before we run the agent?
No, okay. Go for it.
We will do so. This is the fun part, right? So we will run create agent. It's in its own little directory. So what did I do? Oh, didn't source my environment. There we go. Now we'll create our agent. Okay, we've got the agent has been created. We've got the name. We've got the agent ID. And we've got a little thing here to make sure that our ngrok URL is correct, ending in B88. And if we pop down here, yeah, ending in B88, make sure that doesn't change on us. If you run into a 404 error trying to use the agent, it's more than likely that this is changed. Some ordering pieces is out of order. So make sure to take a look at that. Just the way that we're setting this up here with ngrok changing the URL on us, that's and the URL is being set at agent creation time. That's liable to happen. We've got our new agent that's created here. We've got all our instructions that we pass to it. We've got the MCP tool defined in the Foundry. And popping back here, we should be good to now run some inference and actually ask this agent some questions. It picked up the local token, it picked up the server URL, and we should be able to tell me what database tools you can use. Ask it some questions. Okay. Here are all our tools, right? We've got customer management tools. We can create an invoice. We can run SQL. For our local server, we've got these connections, right? Process request of type list tools request. And that is all looking great. So we will, let's go back up here. Let's create a new random customer and then show the details. You see we've got tool calls happening. I'll scroll back up to this output just to see what's going on. So let's see, where did I send this? There we go. Create a new random customer and then show the details. We create a new run. The agent decides to call a tool. It's called the an MCP tool, right? It's got an output with a customer ID, which is how this particular tool is set up. It just returns the customer ID. And then, oh, it looks like we actually got an error in the middle of this. It tried to call the MCP tool again to get the details of the customer it just created. But it tried to run its own SQL instead of retrieve a certain customer ID. So the agent has sent a little message. It says, it seems there was an issue retrieving the newly created customer's details. And it said, let me try again. Let's see. So it ran the tool again. I love live demos, huh? Great. Okay, it ran the customer. Oh my. I have to look at this in the thread log because it's a little bit messy. There we go. It did get the newly created customer details in the end. Let's take a look at that in the Foundry UI. Look at my threads. Pull up this most recent one and playground. Okay, so we see I asked it to create a new random customer. It had an issue the first time, but it did come back with this in the end. And this is kind of the value of having natural language errors, right? That it can actually work from. We pull up the thread logs. Let's see. So this is the first tool call where it is passing arguments to create a customer, right? The name of the tool is insert customer. Let's see. Where did it try to? Yeah, it did a select from customer where customer ID equals 60, right? It got an error. In this next step, it ran list tables because it identified from the error that, right, let's see, no such table customer. So the agent decided, okay, well, I need to figure out what the name of the tool, the tables are. And here we go, name customers, right, is the name of the actual tool. It ran another query to select from customers, and it got the correct response out. So this is just, well, live demos. This is great. It demonstrates the resiliency that these MCP tools can offer you. I think that is pretty much what we wanted to demonstrate with this. So were there any other questions, comments? We can try this with approval mode off if you'd like, Gabe, or what do you think?
I think this is great. That's a good demo. I really like the thread logs on this one, showing the agent looking for a table that doesn't exist. But right. It's nice that it can actually correct itself and still give you an output without you having to reprompt it, right?
Right. Yeah. Try to use any database without understanding the schema first. Good to know the schema before you try to
Yeah,
run a query.
definitely. Nahali, anything you want to add here or comment on?
No, I love the demo. Thank you, Jacob. Just thought, did you want to show um, the inspector again with authentication or
Oh, yes, absolutely. Let's do that. So I'll close our agent loop here. We will, let me go back to README.
just from a troubleshooting perspective? I think that might.
We'll get the inspector again and pull that up. And
Yeah.
we'll pop over to the inspector and we'll punch in the token under the authentication panel here. Oh no, go away. We'll pop up in the authentication under the token here. It populates an authorization header. And I've just got the token from our local, from our environment set up so that we can try to connect with that. And I'm just going to connect through the local URL as well. We could try the ngrok URL just as easily, but we'll just try local and hit connect. And you can see here that we were having some authentication issues. And if we look at the spec, we actually find that bearer does need to be added there in front of your token as well. So I will come back to the inspector, add bearer in front of the token, and connect from there. And we're good to go again. So we've got the MCP inspector working with authentication as well for the server. So we did confirm that, yes, the authentication is in effect. We will fail without that. And we can also see what that looks like on the server side. And once we added our token, we're good to go. So we can come in here and list our tools and do all the same thing that we did. I did want to highlight here too that the reason that the agent had to write SQL to try to retrieve a customer is that we did not give it a separate tool for pulling the data for a specific customer ID. We could do that just as easily, and you can see the danger of having free-form SQL and where the customer doesn't, or the agent, sorry, doesn't know the whole schema, doesn't maybe understand how to use the database straight off the bat. But if we give it a tool for everything that we intend it to be able to do, it doesn't have to understand it, and it works much more reliably. So I did want to illustrate that point while we're here as well. Okay, anything else we want to do with this demo before we move on?
I think I just wanted to call out one observation. I think you covered it already, but in the Azure AI Foundry playground where you had the agent the MCP server that you deployed, it shows up under knowledge, right?
Yeah. So this is, again, a symptom of us not yet having full support for MCP tools in the Foundry. The MCP tool is classified as an action tool. The reason this is important is that knowledge tools are generally limited to one per type of tool. But since the MCP tool is actually an action tool, you can add multiple MCP tools. Again, this will be corrected as we, onboard generally available support for MCP going forward. You can see here the tools that were used to answer each query too. We've got the MCP registered there, but we're working on it. Other thoughts, comments, questions?
Oh, awesome demo. Loved it. Thanks, Jacob.
Thanks. Thank you. So I will kick it back over to you, Nahali, I think, as if I remember right, you wanted to show the full flow again after we covered this demo, just to sort of, now that we've seen it in action, seen what's going on, re-illustrate the connection step by step.
Right. Sure. Thank you. Thank you, Jacob. You could see my screen now?
Yes.
Yes. So what Jacob just demoed, it was this end-to-end piece, all the way starting with the client AI Foundry agent, using the streamable as HTTP transport, all the way to the MCP server that was exposed using ngrok, right?
Right. That's it.
Awesome. So with that, again, thank you, Jacob. I love the details. I think this demo was designed for both our developer audience wanting to know more networking and networking audience wanting to learn a little more on the development side. So I loved your GitHub repo and the details people can follow and step by step and get it up and running, everything that we showed. So any other closing thoughts before we end the recording?
No, great work, everyone.
Thanks.
Great work. Thank you for the demo, Jacob. Thank you for all the visuals, Nahali. I think it's a great demonstration of what we can do with agents and how powerful they can be.
Awesome.
Yeah, I think the last thing I would add is, let us know what else you'd like to see on these, if anything, right? On agents in general, agent framework. A lot of things changing, so there's lots to cover on the subject. But this was great. Thank you for the help, Holly and Gabe as well.
Yeah, good call out, Jacob. Yeah, I think that again, we will continue to have more videos in this series. So do let us know if you want to see something. And as this feature goes out of preview and new features come in, we'll be sure to do more videos. So thank you again, both Jacob and Gabe, for your collaboration. Thank you for watching, and we will see you in the next video.